Everyone, and welcome to the seventh module of the Docker course. In this module, we will learn about defining and running multi-container Docker applications using the Docker Compose tool. First, we will understand the use case for Docker Compose, why it is needed. We will then learn how to install it on a Docker host, and we will see an example to get understanding of Compose. Hello everyone. Till now, we have worked with just a single container at a time. In case of an application which follows microservices architecture, you have multiple layers, each providing a specific service. Each layer would have a different container running, thereby making your application a multi-container application. Running one container at a time and configuring the required dependencies between the different layers would be too cumbersome to do it manually. For such purpose, Docker Compose tool is useful. From now on, we will just call it as Compose. So, Compose is a tool for defining and running multi-container Docker applications. It uses docker-compose.yml for defining the entire application. YAML is the text-based data serialization language. It defines the services, networks, and volumes required for our complete application to run. Services are basically the individual containers that are running on the Docker host. The definitions in Compose are to be made in such a way that the application can run consistently in an isolated environment. The same YML file should be able to run in development, staging, or production environments. Once the Compose is defined, we can get an app running in just one command, which is docker compose up. Now it brings up all the containers with the configuration as defined in the YML file. So using Compose is a three-step process. So let's have a look. For the individual containers, either build image using the Docker file inside Compose or just use an existing image. Secondly, define the services, basically setting the parameters for running the containers and how the containers link with each others. Start the entire app using docker compose up command, which starts the containers as per the services definition. In this nugget, we will learn the installation of Compose. Compose gets installed on top of the Docker engine. So we need to have Docker engine installed as a prerequisite for Compose. On our Docker host, we will use the curl command to download the stable release binaries. The command as per the Docker documentation is sudo curl-l locations of the GitHub release and the current stable release as per the documentation, which is 1.24.0. Now uname-s gives us the kernel name, which is Linux in our case, and uname-m gives us the kind of machine we are using, which is a 64-bit system in our case. It will save the output as docker compose in -user -local -bin. Before running the command, let's check the status of the Docker service on our host. So we'll type systemctl status docker. We see that the service is running. Let's install the Docker Compose. Now the current release is 1.24.0, which is what we want to install. And so let's download first. Now, once the file is downloaded, add executable permission to the binary. That is your sudo chmod +x /user/local/bin/docker-compose. And that's it. Now let's check if the Docker command docker-compose works or not. Docker-compose -version. Which works, and that means the installation was successful and the kind of Compose version we wanted is installed on our host now. Hello everyone. In this nugget, we will understand the Compose concept using an example. We will create an application which requires two services, one MySQL and the other Python. For MySQL service, we will create an image beforehand with pre-populated data. This image would directly be used in the compose.yml. For the Python app, we will create Dockerfile Python service, which means that the compose will have the build instructions for the Python app. The Python app would be using the MySQL service and will fetch the data and print it. First, we will create the custom pre-populated image for MySQL. So let's go back to our host. On our host, we will go to the directory home MySQL, and there we have a file called Dockerfile, right? So let's have a look at what Dockerfile contains. So it uses MySQL as the latest base image. We are setting environment MySQL underscore root underscore password as the admin123, whatever the password is. Then we will add dbinit.sql in the directory docker entry point initdb.d. And then we expose the 3306 on the container. So let's have a look at the dbinit.sql. We use sys as default schema, and then we create a table peoples and insert values to this table. Now let's build the Docker image using the docker build -t. I'll use the pushpum success as a tag and slash MySQL 1 and dot for the current directory as the build context. Okay, so pre-populated image for MySQL database is ready. Do not run the image yet, and let's check it first. So docker image ls command, and we see that the image is ready and it is created 14 seconds ago. Now onto the compose now. I have kept all my files under the directory /home/compose. You will see there are 5 files here. I mentioned earlier that the Python image will be built as part of the compose only using the Docker file. So let's understand the Docker file. Okay, in here I will use Python 2.7 as base image. We will use policy-rc.d to prevent services from starting automatically. We want to control the start, and you will understand shortly why. Specify the working directory, install MySQL-connector-python, copy all files from build context onto the working directory of the container, run apt-get update, set the Debian frontend variable to NN Interactive, and install the MySQL client. Now let's take a look at the compose YAML file. We are using the version 3 of the compose file. Our application uses 2 services. First is MyPython app, and the second one is custom SQL. We are using build with MyPython app. That is because we are building the image as part of the compose. The build context is the current directory. That's why we are using it to dot. For other services, we are using directly an image. The MyPython app service depends on the custom SQL service. Compose starts services in dependency order. The SQL component will be started first and then MyPython. Now that doesn't mean that Python will wait till the MySQL is ready to accept the connection. We will have to handle that separately. We are providing some parameters using the command instructions. Now let's have a look at the shell scripts. So this one is used to check the connectivity of the MySQL and wait for it. Once it is up, then it runs the dbconnect.py Python script to print the data we had put in the peoples table. Then we also specify the Python container to keep running, otherwise it will terminate as soon as the script execution finishes. Now keepalive.py will keep it running. Let's quickly look at the dbconnect.py script now. As you can see, it connects to the other service and prints the first name, second name, address, and the city from the table people. Then it closes the connection. Let's have a look at the keepalive.py script. It just waits in the endless loop so that the container doesn't stop. Now we can start the compose. Docker Compose up. It'll take some time to download all the images here, so I'll just skip some part of the video. It starts the MySQL container first, followed by the MyPython. It waits for the MySQL service to be ready. If you notice, you will see that we are getting the console output from both the services. The name of the service is mentioned first in the log entry. We can see that the MySQL instance got ready, and here we see the output results from our Python container. If I scroll up a little bit, we see that initially we could not make connection to the MySQL service. So as per the script, the Python container waited for the MySQL service to be up. Once the service was up, then we ran the Python script and got the results. Both the containers are still active. Let's open another duplicate session and let's log into that. I'll run the command docker ps. And here we can see that both the containers are in running state. And the image name, let's run the docker image ls. It lists all the images created earlier as well as the ones created as a part of the compose, which are appended or prefixed with compose word in that. So in this session, we created a multi-container application using compose. If the files are copied over to any of the Docker hosts, we will see the same results. Hello everyone and welcome to the 8th module of the Docker course.